Hello, my name is Corbin Lamar.
I'm Miles Gray, and we're part of Team 6929 Data Force. And today we're going to be talking about wiring to you guys and how to have really good wiring on your robot.
So we're first going to start off with why is wiring important. So wiring is important because it's basically what fuels your robot and keeps it running during the match. And there's many different things that can go wrong with wiring that can cause you to disconnect, such as ESD or electrostatic discharge, loose connections, and interference between power and data wires that may cause EMI or electromagnetic interference.
And if you guys have any questions, feel free to just raise your hand and we'll stop wherever you guys have questions. Okay, so here are a lot of phones for the FTC season. There is a huge list of phones, and as you may see, there's 2.4 gigahertz, 5 gigahertz up there. So the difference between 2.4 and 5 gigahertz is that 5 gigahertz is faster, but it doesn't have it doesn't have a bit signal like the 2.4 gigahertz has. So 5 gigahertz, your phones have to be closer together to communicate well. So you know, probably within like 12 feet, like the game field is, you know, that's pretty acceptable limit to 5 gigahertz.
So next we're going to be talking about some control systems. Two possible control systems you may use this year or have used in the past may include the Rev Control Module and the Modern Robotics Control Module. The Rev Control Module is built in with a gyro sensor and also comes with ports for motors, servos, and analog and digital sensors. And with the Modern Robotics Control Module, you will need to buy a SPM, which is a servo power module, to plug in your servos, and a DIMM, which is a device interface module, to plug in sensors that will connect to the robot.
Okay, next we'll talk about placement of modules. So it's very important on your robot, if you have like wires, to not directly connect them to metal, because if you directly connect your wires to metal, like say you have a zip tie connecting wire to the metal, then that wire is you know, in the risk of getting ESD and EMI and then disconnecting your robot. Yes?
How hot do these wires get typically?
They don't, well, for like data wires, not really, but for, or basically any wire on your robot, it doesn't really get hot, but sometimes like the rev hub can get to a high temperature because it's processing so much data and, you know, receiving data. So, you know, you don't really want to run your robot like constantly, like 20 times in a row. You know, you kind of want to, what we kind of do is spread out our practice matches so then our electrons can go down. Yes?
What do sensors do exactly?
We'll talk about that. It's in the slide coming up here. We'll talk about in a second. So, yeah.
So, which system do you think is better, the Rev system or the other centric system?
So both of them have their trade-offs. So with Modern Robotics, you will need to buy the servo power module and the DIMM, as I previously mentioned, and the Rev also comes with a built-in gyro, but it's just merely preference of your team and what you feel most comfortable with.
All right.
The Modern Robotics control system has a lot more modules you would have to mount on your robot. We'll show you guys some pictures of some of our robots wiring once we're done with the slideshow. Oh, I'm not done. Okay, so placement of wires. So we always try to surround our wires in a cover out of plastic. They'll be in the pictures too. But as you can also see here, there's good techniques here. So where it says A right there, there's a tape covering a sharp edge of plastic or metal. So that helps out with, you know, making sure your wires don't get caught. Yeah.
Okay, so plastic covers. Is there a certain type of plastic cover? Do they come in specific sizes?
There's a lot of plastic covers out there. Even you can buy them off of like Amazon. Harbor Freight has them too. But they come in a bunch of different sizes, from like 1/8 inch up to like 5/8, 3/4 inch. So they can get really big for what your needs are.
If you have like the wrong size, will like the wires get too hot, will it melt the plastic?
The wires don't really get that hot, so it's not really a thing to be worried about. Yeah.
Does the size of the cover really matter though? Does it matter? Does it like rub against something else like your motor if it's not the right size?
Well, it's best to have it like, like kind of tight as possible around your wires, so then, your wires aren't flopping around inside there. Because if your wires do like, flop around inside there, it could be prone to disconnect. So what we always try to do is try to have a tight cover around it, and we route wires, data and power wires separate, and we'll talk about that later too, but it's to reduce ESD, so then the power doesn't interfere with your data processing. So and then it's always a good technique to use zip ties wherever you can. We always try to use zip ties every like inch or two on your robot, so then it's you have a tight, it's tied down, and then it won't flop around and then like in a gear or something.
So next we're going to talk, yes?
Are zip ties necessary though? Are they always necessary? Because sometimes like there's sometimes like when some of the parts keep your motor intact or the wires intact really good, is it really necessary to use zip ties, or do you want to like use zip ties for extra security?
Yeah, we recommend using the zip ties for extra security because you can zip tie them to different parts of your robot, and it can also, zip tying can also help the wires to not get caught or be like in an open area where they can possibly hit a game element or possibly get caught in one of your gears or anything of that sort. And next we're going to talk about power and data wires. So you need to keep power and data wires separate to keep down electromagnetic interference, which can power down your robot and make it lose connection during your match. To do this, you need to separate the power and data wires with two different routes.
Okay, next is the grounding cable. Grounding cable is by far the most important part of your wiring. This game rule came out last year. They allowed the grounding cable. Basically what it does is that you can see the yellow connector here. That will plug into your rev hub. If you have modern robotics and you have to do some soldering, you'll have to cut this off, put an power pole on. But basically, you'll have to plug that into your, let's say, rev expansion hub. And then the wire, you can see it has a little nice circle ring at the end with a hole through it. It's perfect for a screw. And then from there, you can mount this metal ring onto any metal part of your robot. So if you do get ESD during the match, it'll go, the electricity will go back into the battery instead of your phone, so then your robot won't disconnect.
So grounding your robot protects your phone from ESD?
Yes.
Perfect.
Yeah, it's really like a really important thing to do for your robot. I definitely recommend, this is the one from Rev Robotics. It's only like $5 and it'll save you some matches sometime. Yes.
It's unlikely to occur, but if imagine one were to create a robot in which two different complexes of metal were separated by a different material, would one require two different grounding cables for each of the metal complexes, since electricity from one would be able to flow into the other?
Well, for your robot, you only need one of them. Yeah. And this is actually required for robot style. You have to have this on your robot because, it just makes everything so much better, so they don't get ESD. Yes.
My apologies. Are these included in either the Tetrix or the other kit?
I do not know. Sorry.
Next, we're going to be talking about strain relief. Strain relief is important because your robot moves around during the match and many wires may become disconnected. And so basically, you can 3D print or create some parts, such as the ones here. So these help keep the cords secure into your device, whether it be your phone or your hub. And that way, they won't come out during the match. And say you have a data cable into Modern Robotics phone cable to the module. And it's basically just to secure that connection and make sure it doesn't come out during the match, enabling your robot to become disconnected and causing you the match.
Yeah, as you can see right here, this is a 3D print phone case that we made. Because like in rescue and during that year we had a lot of phone problems, like phone cable being disconnected during matches. So we made this foam case for velocity vortex here, and as you can see, we used an L-shaped foam connector right here, and then the 3D print part has a back on it, so then the cable literally cannot come out any bit. So it's always into the foam connector. Okay, next is ferrite chokes. Ferrite chokes go on any data wire on your robot. Some phone cables or data cables already have ferrite chokes on them, but you may need to put ferrite chokes on your wires. And what they do is, if EMI does go through your cable, it helps reduce it going to your phone and shocking your phone.
So that's what that technology is.
Yeah.
So we have different types of connectors. So we have the Tamayas, the XT30s, and the Anderson Power Poles. We highly recommend that you replace the Tamayas and the XT30s with Anderson Power Poles, and that is due to basically the connection and having it being secure. So we have the XT30s, and they plug in regularly with little to no connection that like hooks in, whereas based on the Tamaya, you have a stub right here and a hook right there, so it secures the connection. However, we recommend Anderson Power Poles over the Tamaya because inside of this there is a loose connection between the plastic and the connector, whereas in here it locks in and it's hooked around a metal thing, and you can also solder those two motors to replace them.
Okay, now
You recommend the XT?
The Anderson Power Poles.
Okay, next we will talk about sensors and level shifters. So there's a variety of sensor company brands that you can use, and we've used all these sensor companies too, so they're all really good. Smart Robotics, Rev, Adafruit, and Navex. And some of these sensors might need extra soldering to go on different control systems, and then going onto the Rev control system, you might have to use this little thing it's called a level shifter, and converts the logic from 3.3 volts to 5 volts, so then a Rev hub can read the sensor values.
Wait, can you go back to that slide?
Yep.
And all of these slides will be up on the Colorado FIRST website as well.
Yeah.
So that ampage increase to get into the new hub is for which controller or which sensor?
It's for any non-Rev sensor. So any sensor not made by Rev, you'll need to buy this thing. Rev sells it on their website. I don't know how much it costs. They're a little. What is it? You plug it in, and then it has an output, and then you plug it into your Rev hub, and all it does is convert the logic to what the Rev hub can read. Yep.
What is a level shifter?
Yeah. Okay.
Yeah, I can show you guys online. We'll go to the Rev website real quick. Once.
So Rev sells many different components, such as the Rev hub, and also sells different parts for like chassis and different components to build those. Yes.
Those level shifters are only required for the Rev hub.
Yes.
Correct.
So this is a level shifter here. It only costs $3. It's a little tiny thing. It's not that big. It's actually called logic level converter, but most teams call it level shifter just because it's easier. But yeah, that's basically what it looks like.
You potentially need one of those for every sensor.
So for encoders, so say you're using, we'll talk about motors here in a little bit, but if you're using motors from any other company besides Rev, so any more Tetrix, go build up, then you will need this level shifter to convert the logic. Yes. And they have a really good documentation on their website about wiring and like which way to plug in wires to make sure everything's correct. So yeah, that is that. Okay.
All right, we're going to talk about a servo power module this is a Rev servo power module. The Rev servo power module, you can always plug in the servos into the Rev module itself, which will give it 5 volts. But plugging it into a rev servo power module will maximize its voltage and give it 6 volts. That works because you have another connector from here to connector to your battery. Yes.
So this was a little bit, this has to do with sensors again. So when you're working with a robot, do you program your robot using sensors to let's say, move something in its path?
Yeah, so that's basically what sensors do. So sensors get plugged into the rev hub or on our robots would be the core device interface. And when they get plugged into there, your code can read sensor values. So then, say you have an encoder. So when you move the motor, the encoder count will move upwards. So then you can use that that output from the robot in your code to do different things on your robot. And then there's sensors like gyro, which can measure angle. Touch sensors, which, if it's touch, your robot can detect, say like if you have a lift and it's going down and you want to see when the lift is going down, you can have a touch sensor to say do something like that.
And there are sensors in the phone, and there are sensors in the rev module.
Yes, there is sensors in the phone. You could use a gyro inside the phone, but yeah, camera too. I don't know if you need it for this year's game. They didn't say anything about it, but yeah, you can also use the phone camera on your robot. Okay, next we will talk about extension cables and wire gauges. So on your robot, you'll probably need extension cables to go from maybe one side of the robot to the other, or from battery to rev hub, something like that. So, or even for like servos or sensors. So up here are the motor, power, servo, and sensor gauges that you'll need for your robot. And a very interesting thing about wire gauges is that when the number goes down on the wire gauges, so you can see 10 here, that means the wire is thicker. So when you go up with the number, say 22 for sensors, the wire is going to be smaller on your robot because sensors don't really need a thicker gauge because they're not, moving a motor, moving a mechanism or something like that.
Next, we're going to talk about the battery. So there are 12-volt batteries are allowed by Rule RE03 in Game Manual 1, and the ones that are allowed are Tetrix, Modern Robotics, and Rev. And we also, as mentioned before, recommend replacing the connection to an Anderson power pole, and you can do that through soldering. Which there are multiple tutorials online on how to solder, and I believe there's a link in this presentation.
Yeah. So the allowed motors for this year, pretty much every year, are AndyMark, GoBuilda, Rev, and Tetrix. So depending on which sensor which motors you get, you may have to do different things with them. So AndyMark, the ready-to-use right out the box, that come with Anderson power poles right on them. GoBuilda come with a really weird connector on them that isn't that no one really uses it, and it's pretty bad connector. So we recommend cutting off the end of that and soldering on Anderson power poles. And then there's Tetrix, which they're ready to use right out of the box, but the downfall is that there's only one type of motor you can use, and it goes really slow. And then with Rev, they're ready to use right out of the box only for the Rev control system. If you're using modern robotics, then you may have to cut off the end, solder on it and stuff.
So both AndyMark and Tetrix motors already have the Anderson power poles on them?
AndyMark does. Rev has the connector to plug into the Rev hub. They have their own connector. It's called like JST cable or something.
Oh, okay.
Yeah. Yes.
What type of motor does Rev provide?
It's their own motor. It's like a core hex motor, I think that's what it's called. It's on their website. Yes.
Does Rev provide numerous motors? You mentioned GoBuilda only supplies one.
GoBuilda has a bunch of different motors.
I mean, Tetrix.
Tetrix only has one.
So does Rev also have only one?
They have a variety. I'm pretty sure they have like 5 or 6. Yeah.
Can you use any driver-free motors, or do you have to use their code?
You have to use their code that FIRST provides for you.
I don't mean the code, I mean the actual drivers, like the USB to motors.
Oh, you mean like the power cable?
You have to connect it to a
Rev control module.
Yeah, so you connect the power cable to the rev control module.
Or
and
the
you-
modern robotics.
Yeah,
And
or
then can you use any other supplemental devices to help control, like say Arduino, Unos, or anything like
No,
that?
you can't, unfortunately.
That's all I need.
Did you have a question?
I forgot it.
Okay. Oh yeah, and there's only 8 motors allowed
On your robot.
Yeah, only
Yeah.
8.
So say you need to make combinations, so you could do probably like 1 per wheel, and then have the other 4 be for different mechanisms of your robot. Say you have like a lift, have like 2 of them powering a lift, or sometimes you can even gear up or use sprockets to put 1 motor on each side of the drivetrain as well.
Or only use rear wheel drive
What,
instead of all wheel.
servos and motors are separate?
Yes. We will talk about servos the right next slide.
Okay,
Yes.
I'll wait till the next slide.
Okay, yeah, you will talk about servos.
Alright, so there's a maximum of 12 servos on your robot, and the allowed servos, they would be the ones compatible with the Modern Robotics servo controller and the Rev Hub and Rev SBM.
How many rounds are the servos?
How many what?
Grams.
Rams.
Like 12 grams, 18 grams?
Yeah, well, you can get different servo sizes. Like on some of our robots, we use really small servos that are only like this big, and then you can get servos that are like that big. So it depends on which servo you want to get for what it's doing on the robot. Yeah.
So servos are used to connect to controllers?
No, so servos are for like really small tasks on your robot. So it's not for like a big it's not to move like a drivetrain, say. Servos are for like simple tasks. Servos can move 180. They have servos that can only move 180, or they also have servos that can move 360 constantly around and around and around on them. So depending on what you need, you can use 12 servos on your robot.
The servos have a finer control, and typically for like a mechanism that would grab something, you might use a servo to control that, or
Yep.
Maybe you
potentially
need to
lift
flip
the
something.
robot, you might use a servo to do that.
Yep, exactly. Okay, and then wire management. So I talked about a little bit about this before. Zip ties are good to contain wires on your robot, and loose wires can be extremely dangerous. I'll tell you a quick story real quick. To rescue, it was like 4 years ago. We didn't really know what we were doing. We had a data cable that was connected to one of our drive motor controllers on modern robots, and we didn't have it zip tied down well enough. And the wire came undone, and it went into a drivetrain gear, and the wire was totally demolished. It lost connection, and that whole tournament was a total fail because our wiring was not good. So that's why wiring is super important.
Can you still have 2 rev modules on a robot?
Yes, so you can have 2 rev modules on one robot. That's the limit. Yeah. What we recommend is 4 motors on each rev hub, because if you overload the rev hub, then it'll get really, because a lot of power is transferring through there. Oh yeah, and 2 servo power modules you can use on your robot too, because 12 servos, each servo power module can hold 6. Oh yeah, and then over to the right here is a good demonstration of good wire management. So see that, I was talking about this a little bit earlier, see that plastic cover that they have right there, the orange one? They have all their wires going to their arm through that plastic cover, so then none of the wires come out and get in the gear. So that's really good wire management. Yeah.
So is that an example of a chain cable carrier?
Yes.
Okay.
That is an example. And then power switch. Rev sells a really good power switch that we've been using for the past 2 years, and we would definitely recommend for you guys. One thing is that it does have SC30 connectors on both ends, so if you might need to cut them off and then solder on connectors like Anderson power poles or Maya if you need. But the red power switch can handle high currents on your robot. So if you're overloading the mechanism, then the power switch can handle that.
And now I'm going to talk about a wiring schematic diagram. So a wiring schematic diagram helps you keep track of your wires and your connections between different components of your robot. So this is one we had last year, and we had 2 revs. One was in the front, one was in the back, and we had color-coded different things for different color wires for different connections, either from the rev to the servo power module to a servo, rev hub to a motor. And this actually helped us because all of these are in exact ports where they are plugged in on the robot. So during programming, whether you need to get a direct reference to a port, or say you're redesigning a component on the robot and you need to change something around, you can easily take a reference back to this and change it up as need be and know where everything is connected. And if anything becomes loose or disconnected, say during a competition even, you can also take a reference back to this and see where it's plugged in. And you can make one of these. You don't have to use fancy software such as like Photoshop or Affinity. You can use things like GIMP, Google Drawings, or make a hand drawing of it as well.
Okay, quick summary. There's the 2 different types of control systems that you can use, rev and modern robotics. And then mounting the modules is crucial. I'll show you some pictures here of how we mount our modules onto our robots. And then the grounding cable is really important to reduce ESD on your robot. Don't forget that. That one's really important. The wire management is also really important to make sure all of your wires are routed nicely and they cannot come undone and go into a gear like our robot did 4 years ago.
The only ground one of the rev modules?
Okay, I'll show you what we did. Okay, so you see the battery, you see the power switch, and then you see the I don't know why it says T30, but it's T30 distribution block. Rev sells them. Basically, all it does is it has a bunch of different ports on it. It has like 6 different ports, I think. And from there, we take wires out and we put them into 2 rev hubs and then 2 power SPMs. And then, so the grounding cable would get plugged into the first port of the XT30 distribution block. So if we do get ESD, it'll go right back to the battery and not to any of our other modules. Oh, my bad. Okay, and then power switch, it's very important. And then make a schematic diagram of your wiring. It'll help out a ton with programming to make sure, like, oh, what port is this in? So you don't have to go back on the robot and check your wiring and stuff. You'll just have it right away. Yeah.
Will the servos connect to any of the rev hubs?
What?
Rev hubs?
The servos?
Yes.
Yes, they will plug. Okay, so the servos can plug into the rev hub, but it will only run at 5 volts. So the servo power module converts it from 5 volts to 6 volts. So then your servos run at max efficiency and max power and stuff.
And then for a modern robotics controller, you'll need to buy a servo power module, which is also compatible with the rev servo power module.
And then, so that's basically all for this one. Yes.
If you're using the REV node kit, does that imply that you should or have to use the REV control system?
I never heard of that.
REV.
Oh, REV. Okay. So if you're using the kit, you don't have to use a control system. You can use modern robotics too if you want. Yeah. And then here's some resources. There'll be, we'll upload the slide, or you guys can take a picture if you want. You can look up the links. But we'll upload the slide to the Colorado FIRST website after kickoff today.
So when did grounding, I don't believe grounding was a requirement in the past, was it?
Ground wires was a requirement last year, but every year before that, they grounding your robot was illegal. So. They finally, because a bunch of teams were talking about, hey, this could help out a ton, and so FIRST finally listened to teams, and they finally allowed it because they thought it would if one robot did it and a different robot, didn't have it, then that would create a huge problem for teams. Okay, yeah, and any questions you guys have?
Where would these slides be located?
Colorado FIRST website.
Yeah, probably under the FTC section. Any other questions you guys have? Okay.
One more question.
Yeah.
So ESD you talk about a lot, and I don't think some of the younger kids even know what that is. Could you describe what the ESD is?
Yeah, so
ESD is electrostatic discharge, and it's basically the buildup of electricity that gets released when, say, two objects collide with one another. The electricity travels between them and can short out things like phones.
yeah, so since we have foam tiles on our field, foam tiles, they can create static, like if you rub your feet on them, right, with socks on, or like if you do with carpet, and then your robot's basically conducting electricity when your robot can go around the field, and then that buildup of electricity can shock other robots. So that's what the grounding cable helps with. So say one robot's coming around that has a lot of buildup of static electricity, and say it touches another robot, like two metal beams touch each other, metal contacts is what transmits ESD, then it can go into your robot, but since you have the grounding cable, it'll go through the grounding cable, because the grounding cable attaches to your drivetrain, so all that metal's connected, it'll go through there, it'll go into the battery, and then nothing will happen to your robot because you have the grounding cable on. If you didn't have the grounding cable on, then your robot will most likely disconnect during the match, so it'll be really bad.
Or freak out.
Yes.
What's EMI?
Electromagnetic interference. So it's when, like, say you have, so what we recommend is you have data and power cables be separate from each other, like routed separately from each other. EMI is when you have the cables.
So something like a servo connection has both power and data inside.
It doesn't really matter that much because it's not like, the data's, it's only sending like one signal. It's not really like processing or it's not saying like a bunch of data back to the rev hub per se. But
It's also like lower power.
Yeah.
The motors induce a lot more EMI issues.
And we can show you guys some pictures of some of our robots wiring. Okay, so I'll show you guys some pictures from our robots. So we try to make our wiring really nice and make sure like it won't interfere with any mechanisms on our robot. So like how we like to do our wiring, as you can see, the orange cover, it's kind of like a twine thing we get on Amazon, I think. That holds the power cables in them. And then you can see the encoder cables through right here in the plastic covering. And so what that does is the encoder cables go through there, so then the two wires are separated and they will never have contact, and it will reduce EMI.
The encoder is a servo, it's a DC motor sensor effectively, right?
Yes, so you can see right there, the encoder is getting plugged into the motor. So
Encoder's the red, black, yellow, and green.
yeah, so it gets plugged into the motor, and then from there it goes to your rev hub, and that's how you get like encoder counts from your motor.
What motors do you guys use?
We use Go Build motors on our robot. Okay, and then here's some nice wiring from our robot from last year. Yeah, so basically the same thing. There you can see a level shifter, as I talked about before, a level shifter up there. And then you can see the encoder cable right there, and that pretty much just converts the logic to the rev hub. So, pretty nice.
Feedback with the last picture.
Yeah.
Something really good to note on here as well is they have little labels at the end of each cable. So that one has an L on it, noting, something that maybe matches the schematic, or maybe just put a little tag on each cable before you plug it in that says, front right wheel, or label it. Because if you're running a bunch of cables all together through a channel, and then you get them all out to your motor hub, and then you forget which one's connected where, it saves a lot of time. So just label both ends of the cable before you start routing it.
Yeah, makes it really nice, so then you know where everything's at on your robot.
Makes troubleshooting a lot easier rather than trying to follow it all through the zip ties and channels.
So this is on our intake from last year. So we have all this wire cover here, and we do zip tie it to the motor. Not really a problem. Doesn't really matter that much. I know the motor is spinning, motors can heat up, but since we have the wire cover on, the wire, can't really interfere with the motor. And you can also see here, there's a servo. We have the servo surrounding this black cover here, and it's pretty much like a twists around, some more right there to that servo. So this helps out. And then over here we have this big thing on our lift that holds all of our wires together, power and servo wires, all on one big connector, because this lift went in and out, so we want to have all the wires together, be in one smooth motion, because if you have like wires being separately on your lift, it can get, really heavy and stuff. Yeah.
Oh, never mind, I'm sorry.
Okay. Okay, and then this is a robot from 2 years ago. Probably some really good wiring here. So, thing to notice is that last year we used Rev. This is a robot from 2 years ago. We used Modern Robotics, so this is a good example of Modern Robotics here. So, as you can see, we made this 3D printed part here, and right there where my laser pointer is, it has these little blocks on them, so then the data cables can't come out. If you try pulling on them, it will not disconnect it from the motor controller. So as hard as you pull, it will not disconnect from the power distribution line. Yeah.
Since you've experience with both Rev and the core module system, which one would you prefer?
Oh, between Modern Robotics and Rev?
Yeah, Modern Robotics.
So Modern Robotics has a lot, like, if your robot's, say, maxed out on motors and servos, then you can get up to like 6 different controllers on your robot, or 7. Like, because right here, that's a motor controller, or actually, sorry, that's a servo controller. You can see the servos are plugged in there. There's a 12-volt battery cable. So, there's one, but on the other side of the robot, we have like 5 of them. I think might have it. Yeah, see here. So there's 5 different modules. Like, look, there's 1, 2, 3, 4, 5. So there's a lot of wires on this side.
I think there's a cost advantage maybe to the Rev module if you've got a lot of components you need to connect, because in Modern Robotics you effectively have to buy multiple modules for each set of those components.
Yeah, and Modern Robotics is a little bit cheaper, I think, since Rev is out, so they dropped their prices a little bit, I think. But yeah, so Rev, you only need the 2 expansion hubs, and then 2 if you need Rev hub, or yeah, servo power modules, my bad. But yeah, you can see good wiring here. Here are the 2, these are 2 data cables, so then the motor controllers know what to do. They go with this black. We do use 3 different types of wire cover. We use this orange one, we use this clear twisty one, the black twisty one, and then this other black one we use for data cables here. So yeah, so these cables go through this black wire down here, and then here's an encoder cable. You can put encoder cables and data cables next to each other because they're both transmitting data, so it doesn't really matter. And then you can see all of the power cables are separated. As you can see, they're like right in this area, so up here. We try to keep them separated as good as possible. Here's some good. This is the bottom of the robot. You can see data cables, how nicely they're run under the robot. And you can see zip ties are there approximately every 1 inch or so. And then we also have servo wires right here. That's to them, because it doesn't really matter too. And then up here is power cables. So see how we keep those separated from each other as good as possible. And then Yeah, this is from Rossi Vortex. Big. This wire held like 4 power cables in it, going from one side of the robot to the other. Because, see, the bad thing about modern robotics is that if you have your modules on one side of the robot and then modules on the other side of the robot, you will have to transmit power from both sides and data cables. So, it can get up to a lot of wires going from one side of the robot to the other. And here, same thing, like black is data, the clear is encoder cable, and this is our, this year we had a big nest of power cables in this one area, and it kind of filled up a lot of room. But yeah, we try to use zip ties as, wherever we can on our robot. But yeah, that's all the pictures I have. Do you guys have any other questions?
I think something worth noting is just where you're putting the modules is make sure that you can get at them so they're easy to plug stuff into and see status and everything, but also not too easy that another robot can bump them or hit them. So you don't want them buried underneath, but you also don't want them just right on the outside surface.
Yeah. We try to keep our modules inwards towards the inside of our robots, away from plastic outside, so then if someone does come and hit us, the modules won't shake or get impact from the robot hitting us. So.
And that goes with the phone as well. You need to keep that more inside the robot where other robots can't bump it and disconnect the phone cable as well.
Yeah, because if you think about the phones, pretty much controlling your whole robot, so it's a really important part to keep that safe and in a safe place and have good connections on it. So, yep.
What phones were approved for this year?
We had it at the beginning of the slide. Okay, they're the approved phones for this year. They're all Android phones. You have to use Android phones, and you have to use. You can use any one of these phones on your robot. So, the 5 gigahertz phones do cost a little bit more money, but you have the extra Wi-Fi channels on them if you want faster processing, faster communication between the robot and your driver station. Yeah.
What hertz setup would you prefer?
The 5 gigahertz. Because the 5, okay, good thing to note is the 5 gigahertz phones can also run at 2.4 gigahertz. So.
Repeat that, sorry.
The 5 gigahertz phones can also run at 2.4 gigahertz.
Okay.
Which phones do you guys use?
We use the Motorola G5. Yeah. But we've also used ZTs and G2s in the past.
So did you say that the 5 GHz has worse connection?
Yeah, so it has it can't travel as far, so then you can't go really far with the phones. But since our field isn't that big, it's okay. But it does have faster Wi-Fi connection on them. But yeah.
So iPhones aren't allowed?
No. Yeah, one thing to do note is that the Samsung Galaxy S5, I know it is 5 gigahertz, but it only has one Wi-Fi channel that you can use on it. So it's pretty bad. I wouldn't recommend using that.
How many phones can you use?
2 phones, one on the robot and then one on the driver's station. But you can have as many phones as you want. We have backup phones.
But there are only 2 in use at the competition.
Yes. Yes. Okay, I think we'll end there. Yeah. You guys have any more questions?
Would an operator use the phone as well as the robot?
Yes. Yes.